Hello all. Now I'm going to tell you about the selection of motor power rating. The factor affecting on the motor power ratings are: the first one, heating effect; second one, class of duty or loading condition; third one, inertia of load; and the fourth one, environmental condition. So let us see the first factor, heating effect. So the temperature rise is limited as it depends on the insulation quality. So as we know, there are different types of insulation available for motors, like A class, B class, H, E, F. So let us say, suppose a particular motor is designed for A class, so it is called as a non-standard motor, and one motor is designed for E class, H class, B or F class insulation, it is called as a standard motor. There are some factors which are affecting the temperature rise. The first one is heating, and that heating may be caused due to copper losses, iron losses. And the second factor on which the factor or the temperature rise depend is nothing but the heat dissipation. Heat dissipation is nothing but the how much amount of heat is dissipated due to conduction, radiation or convection, as it depends on steady state temperature rise. So what is exactly steady state temperature rise? The steady state temperature rise is nothing but the heat generation rate which is equal to the cooling rate. Let us consider a situation at which we can't increase the insulation quality. That means particular wire is provided and we are not able to replace that wire. So in that case, the factor which can be adjusted to decrease the heat dissipation is nothing but the factor which is we can't change the wire and already available, as it is already available. In that case, to maintain steady state, we have to increase the heat dissipation by providing fan, hydrogen tube, oil, so that heat dissipation will increase, or we can increase the effective area. The third factor on which temperature rise depend is called as a specific heat capacity. The specific heat capacity is nothing but the property of material, and its values varies as per the material capacity, and it is defined as S is equal to J divided by kg degree Celsius. That is nothing but the energy required to increase the temperature of body by 1, that is increase the temperature of 1 kg of material by 1 degree Celsius. And material can be selected having high specific heat capacity. If material is having higher specific heat capacity, the time required to increase the temperature is also higher. Therefore, the more time will be taken for heat dissipation and steady state condition can be achieved. So let us derive the equation. Let us say H is nothing but the heat generated in joules per second, W is nothing but the weight, that is active weight, S is nothing but the heat capacity, that is specific heat capacity, A is nothing but the effective area of cooling surface, and lambda is nothing but the dissipation constant in joules per second per meter square per degree Celsius. That is, if we consider the 1 meter square area, lambda is nothing but the heat dissipated per second per degree Celsius, that is energy release per second per meter square per degree Celsius. Let for time t, rise in temperature is theta, and for a small time dt, heat generated will be d theta, and it will be H into dt is equal to lambda dt a theta plus SW into d theta. That is nothing but heat dissipated plus heat generated. Let us divide both sides by dt. So H will be lambda a into theta plus SW into d theta by dt. After doing some rearrangement, d theta by dt plus lambda a theta divided by SW is equal to H upon SW. This is nothing but the linear equation. By solving this linear equation, the solution of linear equation gives theta is equal to H upon lambda a in bracket 1 minus e raised to minus lambda a upon SW into t, where SW upon lambda a is nothing but tau. If we consider the condition at which T is equal to infinity and theta at that temperature, means at T is equal to infinity time, theta will be theta m. By putting the value in above equation, we will get theta m is equal to h upon lambda a. Therefore, the above equation can be rewritten as theta is equal to theta m into 1 minus e raised to minus t upon tau. By using this equation, if we are going to draw the heating curve, it will be looks like this, and for cooling, theta is equal to theta m into e raised to minus t by tau. So in next lecture, we'll see the duties of motor. Thank you.